Hello everyone, so this is the first video of my CNC mill project. I decided to make this first video for people who want to know how I build my machine. So I'm gonna show you my CAD and explain my choices and all the reflection behind multiple parts of the system. First I'm gonna start with the X-axis cross slide. So I did two versions of this, and this is the first one. The 24mm thick plate and these two beams are the main structure and gonna support all the components. These three parts and the milling table, who is this part, will be ordered already cutted at the dimension and rectified to reduce the cost. About the components for this axis, for the motor I decided to take a NEMA 34 stepper motor. He's gonna have enough torque for this task, maybe too much, but this is good. About the ball screw, these are Chinese but good quality 20 meters ball screws. And that's the second version. I just replaced the two beams with 4 wedges because I can make them with my lathe and my 4-jaws chuck, so reduce the cost. I'm almost sure that I will take the first version because the beams helps a lot to have a better rigidity, but let me know in the comments which one is the best and why. I also made some experiments, especially for the second version, with this 3D printed prototype. This was useful to see what the screw holder wedge will look like, because this one is the same for both versions. I didn't measure or test the accuracy because of the plastic, but this was useful to me for checking and buying the good screws length for the blocks and the nut holder. For the Z axis I also did two versions. This is the first one. It will be 4 rectified aluminium or steel plates bolted together. The two beams leave place for the ball screws and stuff, and the spindle would be put on this plate. For the beams and the plates I did a quotation, and in aluminium there is almost 300 euros of rectification, so it will be a bit expensive. This is why I made a second version. I think I would normally take it. It's made out of 2 steel metal plates welded on one extrusion to move the spindle axis at the center of the milling table. About the components, I decided to use 20mm linear guide and 60mm ball screws and NEMA 34 stepper motor. I'm now working on a counterbalance systems with chains, so the ball screw is gonna support zero load apart the acceleration and movement. The counterbalance will also recover a part of the moments of the spindle weight. For the spindle, I think I will normally take a 2.2 kilowatt Chinese motor that we can buy on eBay for 200 bucks. But I'm also thinking about using a block spindle driven by a belt and a servo motor, who can be more rigid and have a better accuracy, but this is more expensive and need more parts and machinings. Now I'll talk about the main frame. It's divided into 2 big parts who's gonna be bolted together, and in all this extrusion I will normally put some epoxy granite to raise the weight of the machine. What you see now is a horizontal pattern and also the y-axis, who is composed by a main chassis made out of these 100 by 150 steel extrusions, and on this structure I'm gonna weld 20mm thick steel plates who gonna be the reference surfaces and support for the rails and the column. I'll use these 25mm Hiwin rails and this type of attachment, and 20mm bar screws to still have a good rigidity and no backlash. I worked on the machinability of these big parts, and I'll use a bigger mill to machine these surfaces. To respect all the specifications of flatness, I will first machine in one operation those plates that I have pointed to have a reference surface. So now I can hold on this surface and mill all the functional surfaces moving the part, because this bigger mill can't machine it in one operation. Now you can have an idea of the process with this animation. Thank you to Desnoza for this animation. I give you his contact on the description below. For the column, who is the z-axis, this is all the same deal except these surfaces who has to be perfectly perpendicular. So this is why I will need a horizontal mill to do this. For the other surfaces, nothing has to be especially prepared. I use two 140 by 140 extrusion and 20 mm thick steel plates. This is the end of the video. Thanks for watching. The episode 2 will be on the horizontal frame manufacturing, and when you are watching this video, it is completely welded and finished. And you can check the description for specs about the machine. See ya.